This conference will now be recorded.
So very good evening, students. Today we are back with JEE advanced questions on electrostatic chapter. So we have few questions for today. Let us discuss those questions. So the first question says, an infinitely long, thin, non-conducting wire is parallel to the z-axis, carries a uniform line charge density lambda. It pierces a thin, non-conducting spherical shell of radius capital R, as you see in the figure, and R, okay, in such a way that the arc PQ, this is the one, this arc makes an angle or subtends an angle 120 degree at the center of the spherical shell, as shown in the figure. So the question says that there is an infinitely long line charge having charge density lambda. Okay, so line charge density lambda. Okay, and this line charge is actually piercing a thin spherical shell of radius capital R. As you see, this is a thin spherical shell, just like a plastic ball. If you pierce a plastic ball with some wire and just pass, if the wire passes through that, this is the situation similar to that. Okay, so you see this is the arc. This is actually, this will look like this. Okay, this is thin spherical shell, and that spherical shell is making an angle or subtending an angle. This is kind of a solid angle, so this is not linear angle, solid angle. Okay, this is because this is the area, or in this case at least we can think that is a thin. Okay, so we can think as since it is thin shell, we can take this as just arc also. So in that sense uh, it is a linear angle 120 degree, which is subtended at this center of the cell. And see, the wire is parallel to the z-axis, and z-axis, as you see, it is passing through the center of the cell. Okay, so this PQ arc is making an angle 120 degree at the center. This is the clue point, or this is the vital point we should actually note from this figure. Okay, fine. Now the question is that the free space permittivity, the permittivity of free space is epsilon naught. Which of the following statement, which of the following statements is or are true? That means there may be more than one correct answer or correct option. Okay, we have to choose the right option in this problem. Okay, so let us first read the problems, options. The option is the electric flux through the cell is 3r lambda divided by epsilon naught. That means we have to find out electric flux through the cell. Okay, Then second thing is the Z component of the electric field is 0 at all the points on the surface of the cell. We'll see that. And the electric flux through the cell. So there are two options with electric flux. And electric field is normal to the surface of the cell at all points. So all right, we'll just see which are the right options. Here there is a printing like typos. So this is option C and this is option D. Okay, this is option D, this is option C. All right. So first of all, let us see this line charge. See, line charge always have a cylindrical symmetry, as you know. There will be cylindrical symmetry. Okay. So when there is cylindrical symmetry, the electric field always will be radial. That means electric field will be along this direction. Okay. I mean to say, if this is the surface, so it will be uniformly distributed along the radius of this. Okay, so there will be no electric field component along this direction. Okay, no electric field component will be there along the Z direction. All right, so the second option, look, the Z component of the electric field. Z component of the electric field is 0 at all the points on the surface of the cell is correct. Okay, because electric fields will be in this direction, in this direction, in this direction, in this direction, but not along this direction. There will be no electric field because the electric field lines will be radially emerging out from the wire. Okay, thin wire or long line charge density. Okay, in this direction there will be no electric field component. Therefore, option B is correct. Okay, see, this is option C, this is option D. Now, the first option with electric flux through the cell. See, we know for a line charge, electric flux through a closed surface, or for the long charge, like long line charge, it is actually lambda L by epsilon naught. But this is charge enclosed. Lambda L is the charge enclosed. But the question is, what is this L? What is this L? This L, actually, see, wire will be always infinite. Wire will be infinite, but this length is actually the length of the Gaussian surface if we apply the Gauss's law. This is according to Gauss's law. Gauss's law. So this L, this length is actually the length of the, or height of the Gaussian cylinder. Okay, Gaussian cylinder. So in this case, if we draw Gaussian surface or Gaussian cylinder, that will actually be in this, right here, with the, that will have the length of PQ. Okay, so in this problem L is the length of the arc PQ, length of the arc PQ, right? So how to find out this arc length? Okay, so look, if I just draw a perpendicular over here, perpendicular bisector for this particular angle, so this will be 60 degree. Okay, so suppose this is PS. Okay, PS or PS, right? So this length PS, see, PS by, so this is 90 degree, so PS by This suppose base SO, PS by SO will be sine 60 degree. I hope you agree with me. So if I just draw a perpendicular bisector for this angle POQ, then this angle will be 60 degree. Similarly, this angle also will be 60 degree, and I can write PS is equal to, see, SO means R, nearly radius. Oh, I'm sorry, this is actually a little bit wrong. This should be PO, not SO. The sine theta. Sine theta means perpendicular by PS by PO. This is PO. PO is actually R. PO, not PQ. PO. PO, this is R. So PS will be R sine 60 degree. Therefore, PQ will be 2 of this PS. So this will be 2R sine 60 degree. That means it is 60 degree root 3 by 2. Root 3 by 2 into 2. So this will give ultimately root 3R. Okay, root 3 by 3R. So we have got PQ. Then what is the flask? See, flask will be lambda into PQ by epsilon naught. Okay, so PQ is actually root 3R, then lambda is there divided by epsilon naught. So we have got the answer. I hope there is some mistake in this printing, like in the typo. This should not be 3, that should be root 3 actually. Just a minute. Yes, this option is actually with root 3. Okay, root 3 R lambda by epsilon naught. Okay, this is the correct option. I have somehow I have typed in it wrongly, so this is the correct option, and we see here we have also got the same value, root 3 R lambda by epsilon naught. So the electric flask through the cell will be root over 3 R lambda by epsilon naught. This is correct option. So we had seen the option B also were correct, because Z component of electric field will be 0 all over the surface. Okay. Now option C and D we have to see. See, electric flux through the cell, we have already found out this one, so this is obviously wrong. Now the option D, the electric field is normal to the surface of the cell at all points. Okay, we have to see when we have a simple conducting cell, then electric field lines will be always normal to the surface of the cell if it is conducting. Okay, if it is conducting, because it is emerging out or it is producing electric fields by its own. But when the wire is passing through this, electric flux is not due to the cell because it is non-conducting cell. So in this problem, the cell is non-conducting, so it is not producing any electric field. Cell is non-conducting, hence it is not producing any electric field. It is not producing any electric field by its own. And electric fields are emerged out from or are emerging out from the line charge. So therefore we cannot claim that electric field lines will be perpendicular to the surface. That we cannot claim. Okay, so that's why option D is wrong. Okay, wrong. Electric field is not normal. Actually we cannot say it will be normal to all the points. Okay, it may be normal to some points, but it may not be normal to all the points of the cell. That's what we can say, because see, if the electric field or the charge, if there is any charge at the center, then electric fields will be emerging out radially outward, then that is true. But as the spherical cell is not producing any electric field by its own, and the electric field is produced by only this wire, okay, of length PQ arc, then electric field may be perpendicular at some points of the surface, and but not at all the points on the surface. So that's why it is wrong. Okay, so these two options were wrong. First two options were correct. All right, we'll move on to the next problem. So this problem is from JEE Advanced 2018. As you see, this is also a very interesting problem, an infinitely long uniform charge, but say the same kind of problem. This is also because this is also with infinitely long charge, having charge density lambda, etc., with the same kind of charge distribution. Okay, and same Gauss's law we have to apply here also. An infinitely long uniform charge, the distribution of charge per unit length lambda lies parallel to the y-axis. So you see this is the wire which is actually parallel to the y-axis, and it is lying in the yz plane. Okay, it is in the yz plane at a distance √3/2 a from the y-axis. Okay, from the y-axis. If the magnitude of the flask of electric field through the rectangular surface ABCD, so this is rectangular surface ABCD, ABCD. This is rectangular surface where it is in the xy plane. That means here somewhere, okay, in this actually, in this, as you see in the figure. So this is parallel to the this again. So this is uh, on the xy plane, and the wire is actually in the yz plane. Wire is in the yz plane. See, since okay, so the question is, if the magnitude of the electric flux through the rectangular surface ABCD lying in the xy plane with its center at the origin O, that means the surface has its center at the O, is, so the flux is given actually, what is that? Lambda L by N epsilon naught. So what is lambda? Lambda is the charge density, as you know. L is the length, sorry, breadth of this surface, and N is the unknown number, what we have to find out here, as and epsilon naught, you know, the electric permittivity in free space. Okay, so you have to find out the value of the N, where the electric flux through this surface ABCD is given. So in the previous case we have seen, see, always this thing we have to remember whenever we apply Gauss's law. So charge enclosed, this should be charge enclosed, this charge enclosed should be enclosed by the Gaussian surface. Okay, so charge has to be enclosed by Gaussian surface. If any charge is residing outside the Gaussian surface, that will not contribute to the electric flux. So this is the true fact you have to understand. Now we see, since this is in the YZ plane, this wire is in the YZ plane, and we are, or this surface is in the XY plane. So the whole wire may not be contributing to the electric flux. Okay, so if we draw some perpendicular from the plane to that particular wire, see, it looks like this. Okay, the particular point, suppose this is the point of intersection of the, see, if I just draw this like this, oh sorry, this goes up to here, B. Okay, so if you draw this, as you see in this figure, if you draw perpendicular, or perpendicular need not be perpendicular, let us draw some line up to the point uh, at height Z. Okay, at height Z. So this is the point at height Z, and Z has a value √3/2 into A. Up to that point, or up to the wire, if we just draw a line, this is, see, if I say this is the point, this point, some point, suppose say it is P, so here it is P, so AP, and this is BP. So two lines I have drawn, and this is AB. You look here, okay, this is AB. So I have drawn two lines up to the wire, and let us take that point is P, common point. Okay, and we are adding. See, why we are doing this thing, you might be a little bit surprised why we are doing this. Because see, electric field will be, see, in this case also it has actually radial symmetry of electric field lines in this line charge, you know that. So electric field is actually uniformly distributed out, or electric field lines are emerging out like this all over the, like uniformly over a like in 360 degree, okay, 360 degree in all directions. But all the electric field lines will not contribute to the flux which is passing through this particular area, surface area. Then we have to choose some solid angle from the surface, some solid angle or some angle which is subtended by the edges of this surface. So that those electric field lines which are just inside that angle subtended by the edges of this surface will actually contribute to the electric flux through this ABCD surface area. So that's why if you draw this figure, it is now very clear. If suppose the angle between this line, say this is PM, so PM, see, if it is an arc, this A and B, this arc is subtending an angle 2 theta at the point which is on the line charge, 2 theta angle, and this is actually a perpendicular bisector PM. Now this is angle theta, this is 90 degree, same thing here. So now if I write tan theta, so I have to find out actually theta, and by doing that we have to find out actually the length of this arc, because we have to find out phi means lambda L by epsilon naught, and L here is the length of the arc A and B, or simply AB I could say. So length of this arc A and B would be the length of this wire, which I can put here in the Gauss's law. So we have to first find out what is theta, okay, and what is 2 theta. From there we can find out the length. Okay, so tan theta is equal to perpendicular by base. So perpendicular is how much? This is the perpendicular, because this is A. You look here, it is A. Sorry, this is okay. So I should have drawn like this. Okay, I should have drawn like this up to here. Just a minute. Okay, so look, this line. Anyway, you have understood. I hope you have. So we have to draw like this. Okay, so this particular line, this AM. Okay, let me just first write down what is tan theta. Tan theta is perpendicular PM by base. Base is actually, sorry, perpendicular is AM and base is PM or MP. AM and this is PM. So AM is already given. This is height root 3 pi 2a, and so AM is that AM is a by 2. Okay, a by 2. All right, this is a by 2, and PM is root 3 A by 2. So this 2 goes up, this also goes up. So 1 by root 3. That means theta will be 30 degree. Okay, because tan 30 degree is equal to 1 by root 3. So the total angle will be actually 2 theta, which is actually 60 degree. So 2 theta, see now I have to find out what is the arc length. Okay, so the arc length will be actually, this I don't know, so we don't go in that way. So arc length will take 120 degree divided by 360 degree. Okay, that's how we'll get 1 over 3. Okay, 1 over 3 will get. So that is the arc length. Now if we see this, oh I'm sorry, this is 60 degree, not 120 degree, this is 60 degree, 2 theta. 2 theta is 60 degrees, so it will be 1 over 6. Now if we find out the flask, lambda L by, so L is actually L by 6 now, 6 epsilon naught. Okay, so but in the problem it was given lambda L by n epsilon naught. So comparing these two, we get n is equal to 6. Actually this is the answer. Now we'll move on to the last problem for today's class. So this problem is very simple, even though it looks like a lengthiest one or the longest one. So the problem says the electric field E is measured. Electric field E is measured at a point P is equal to 0, 0, D. That means if you think XY plane, so it is in the Z, okay, at a distance Z. So if this is the plane, so it is measured at some distance D over here. Okay, so this is suppose Y, this is X. So it is measured at D distance, generated due to various distribution of charge. Okay, various charge distribution, and the dependence of electric field on D on distance is found to be different for different charge distributions. Okay, so dependence of electric field on the distance D is found to be different for different charge distributions. Okay, now I have two columns, so or two lists. Suppose this is list 1. Okay, list 1, and this is list 2. Okay, I have two lists where in the first list dependence or the relation between the electric field and the distance is given, and in the second list the details of the charge distribution will be given. I'll write each of them, then it will be very clear to you. So first it says E is independent independent of D. Let me first fill the list A itself. Of the B is saying 1 over D. C says is direct inversely proportional to the square of the distance. D says E is inversely proportional to the cube, or D cube, inversely proportional to the D cube, distance cube. Okay, so these are 4 options or 4 variations of electric field with D, or 4 relations of electric field with D. Now I'll write 5 uh, 5 different charge distributions. So name is P. This first option is P on the list 2. A point charge Q at the origin. A point charge Q at the origin. Q says a small dipole with point charge charges Q at 0, 0, L and minus Q at 0, 0, minus L. Okay, and take, it says take 2L much less than 2L, that means the length of the dipole is much less than D. Okay, then PQR, R says an infinite line charge coincident with x-axis with uniform charge density lambda, with uniform uniform linear charge density. Uniform linear charge density lambda is, I think I have to write the last option in the other page. S is also too big. Let me just continue. Two infinite wires carrying a uniform linear charge density. Two infinite wires. Infinite wires. Wires carrying two infinite charges, line charges, or infinite wires carrying uniform linear charge density parallel to the x-axis. Along x-axis. And furthermore, there is some more information. Along, the one along y is equal to 0, y is equal to 0, z is equal to L. One along y is equal to 0, z is equal to L has charge density plus lambda. Okay, so having charge density, having plus lambda, I'm writing charge density lambda, and the other along y is equal to 0, z is equal to minus L has charge density minus lambda. Here also you can take the dipole to be point dipole. Okay, and the last option says infinite plane charge coincident with infinite plane charge. So option T, infinite plane charge coincident with the xy plane. XY plane with uniform surface charge density. With uniform surface charge density. Okay, so we have to match. There are options actually. I'll write the options over here. The first option says, let me see. Okay, the first option says A matches to T, A matches T, B matches R, and R and S, R comma S, B matches R comma S. Option B says A matches to T, B matches to R. That's all for this option. Option C says, oh, there are few more things. C matches to P, D matches to Q. PQ, here this is a small q, small r st, okay? So here in this option again, C matches to P and D matches to Q. This is what says, okay. Here option B, so here C matches to P, D matches to Q, the same thing. C matches to P and D matches to Q. The answer is very simple, but the question is very long. So that's why you have to be little patient to read the question and then answer it. A matches to T, option C says. B matches to R, okay. C matches to P, Q, D matches to Q. C matches to P, Q, D matches to Q. And the last option says, oh, here there are three options alone, okay. D matches to S here, all right. D matches to S, okay. So there are three options only. We have to solve this problem. I'll just read out quickly the whole problem and then we'll solve it. This is very simple problem, but the question is so lengthy. Sometimes we may be a little bit hesitant to attempt this question, but this see, lengthy questions always will not be very tough. Okay, actually, lengthy questions sometimes may be very simple questions. Okay, questions to answer, and short questions like very two lines questions may be very tough to answer. All right, let us see. See here the see E is independent of D. See, electric field is independent of D only for the plane, infinite plane charge, like plane, infinite plane, conducting plane having charge density, surface charge density sigma. So we know in case of plane, infinite plane, electric field is to be sigma by 2 epsilon 0. Okay, it does not depend on any distance at all. Okay, it doesn't have any space variations. If you go this way, any way you go, either side, the electric field will be sigma by 2 epsilon 0. Okay, since it is, if it is positive, then this side it will be this way, electric field will be radially outward. Okay, this is the direction. All right, so it is independent of the distance. So first option actually will match with, see, first A will actually match with infinite plane charge coincident with xy plane. So A is matching with D, that is correct. And everywhere it is there. Okay, we cannot conclude anything from here. The second thing is E is directly proportional to D. Sorry, inversely proportional to D. This option is, see, in case of infinitely long line charge, in case of infinitely long line charges, we know the electric field will be, see, for infinitely long line charges, electric field actually becomes lambda by 2 pi epsilon naught d. Okay, this is the electric field. Okay, this is the electric field. So for line charge, it is for infinite line charge. So better to remember the results of each symmetry. So the option B matches with matches with infinite line charge, that is R. Okay, B matches with R. That is true. So B matches with R. Okay, B will be matching with R. So B will be matching with R. Now let us go to the C. C is 1 by d square. It is actually for point charge. If you keep the point charge at the origin, then it is true. Okay, so at least we can see now C is matching with P 1. Let us see if something else also matches with C. Let us read the option Q first. So here dq 1 over dq. So this is for dipole. We know every one of us may know this is for dipole. Okay, this is for dipole. Okay, so dq will be for dipole. As you know, it is for dipole. Okay, so for dipole only, electric field is inversely proportional to the cube of the distance. Okay, so D will be matching with Q. That is true. Now S, we'll see S. In case of S, the electric field, see here we have to read the two infinite wires carrying uniform charge, line charge, linear charge density along x-axis, one at a distance z is equal to L, another one along minus z. Let us try to see the situation. Okay, so this is z direction, suppose. Okay, so the point where we are finding out electric field is this 0 0 and D. Say this is the origin. Okay, and this is x-axis, maybe this is y-axis. Okay, anything you can take. So let us take this as x-axis, this is y-axis. Now the thing is that the infinitely long charges, one is at y is equal to 0 and z is equal to L. See, z is equal to L, suppose this is z is equal to L, y is equal to 0. So from origin, this is origin, it is somewhere like this. Okay, this is somewhere like this. This is infinitely long charge and it has lambda plus lambda. Okay, and if I say, okay, let me just see whether the, okay, along x-axis, the charges are along x-axis. We can draw along x-axis, doesn't matter. We can draw this along x-axis like this. Okay, along x-axis, the infinite charge, infinitely long wire. Okay, so this is along this way, and it is at distance how much? L distance. Anyway, this is perpendicular to z-axis. Okay, so this is L distance away. This is D, so this distance is D minus L. This is D minus L. Another one is at minus L here. Okay, this is Z axis is on the other side, so this will be parallel actually. Okay, oh, I'm sorry, this is one along one here. Okay, another one is here. Okay, so this is actually if this is D from this point or from the origin, if we say this is L distance away, and from this is actually L distance away on the either side. So electric field due to this wire will be lambda by 2 pi epsilon naught. One will be d minus L, okay, d minus L, and this is with plus, this is minus lambda by 2 pi epsilon naught. This is lambda plus, sorry, L plus D, L plus D, or D plus L, you can think, D plus L. Okay, so if you solve it, the electric field will somehow come like d square. Okay, electric field will be 1 over d square only. Okay, so for this case also the option S also comes like 1 over d square. Okay, so option A comes like 1 over d square. That means it is C matches with both points at P and S. Okay, we'll see which option is correct, because A to T, so A to C, P and C will match with P. Okay, I think, let me see if I have done or I have written something mistakenly. Yes, actually the option B has C, here there was S, PS. Okay, so option B will be correct answer here. So A to T, B to R, P to C to P and C, and D to Q, D to Q, C to P. So it will be the option B. Option B will be correct answer for this question. So the question was very simple, but since I had to write all the way, so this becomes a little lengthy. And if you see in the question paper also, it looks like a very lengthy question, but it is very simple. Okay, you have to attempt this kind of problem. Just by seeing the length, you should not judge it. Okay, so thank you for your patience. Bye for today.